Good morning everyone. Today we are going to see the facade design pattern, which is a structural design pattern. In this presentation we are going to see the intent of the facade pattern, motivation behind the facade pattern. So where we are going to apply this facade pattern, structure of the pattern, and what are the different participants of the facade pattern, and what are the different collaborations of participants in the facade pattern, and consequences, pros and cons. Next we are going to see how we are going to implement the pattern and non users, and next we are going to see the related patterns with the facade pattern. So the main intent of facade design pattern is to provide a unified interface to a set of interfaces in a subsystem. And this facade also defines a higher level interface that makes a subsystem easier to use. That means this particular pattern provides a specified interface to a library or framework or any other complex set of classes. So, structuring a system into subsystems helps reduce complexity. A common design goal is to minimize the communication and dependencies between subsystems. One way is to achieve this goal is to introduce a facade object that provides a single, simplified interface to a more general facilities of a subsystem. So now we'll consider one example, a programming environment that gives application success to its compiler subsystems. So this subsystem contains classes such as scanner, parser, program node, bytecode stream, and program node builder that implements the compiler. So some specified applications might need to access these classes directly, but most clients of a compiler generally don't care about details like parsing and code generation. They merely want to compile some code. So for them, the powerful but low level interface in the compiler subsystem only complicate the task. So to provide a higher level interface that can shield clients from these classes, the compiler subsystem also includes a compiler class. So this class provides a unified interface to the compiler's functionality. The compiler class here, it acts as a facade, so it offers a client a single or simple interface to the compiler subsystem. It glues together the classes that implements compiler functionally without hiding them completely. So here the compiler facade makes life easier for most programmers without hiding the lower level functionality from the few that need to. Applicability. So where we are going to use this facade pattern. Use the facade pattern when you need to have limited but straightforward interface to a complex subsystem. And we can use this facade when you want to structure a subsystem into layers. So the structure of the facade is given in the figure. So the participants of this facade are facade and subsystems, as you are seeing in the figure. So here the facade is in the figure it is represented as a compiler. So this knows which system classes are responsible for the request. So this facade knows who is going to which subclass system is going to request, and it also delegates client requests to appropriate subsystem objects. The second participant, subsystem classes. So in the figure, it can be a scanner, parser, program node, etc. Anything. So this subsystem classes implement subsystem functionality, and this will handle the work assigned by the facade object, and this has no knowledge of the facade, that is, they keep no references to it. So now we'll see the collaboration among the participants of the pattern. So here the clients communicate with the subsystem by sending requests to the facade, which in turn forwards them to the appropriate subsystem objects. And here the clients that use the facade, there is no need for the clients to access the subsystem objects directly. And here, coming to the consequences, the benefits of facade are: this protects clients from subsystem components, thereby reducing the number of objects that clients deal with and making the subsystem easier to use. And it also promotes weak coupling between the subsystem and its clients. So often the objects in a subsystem are strongly coupled. So this weak coupling lets us to vary the components of the subsystem without affecting its clients. Coming to the con, a facade can become a code object coupled to all classes of an app. Several steps are there for implementing the pattern. Check whether it's possible to provide a simpler interface than what an existing subsystem already provides. So you're on the right track if this interface makes the client code independent from many of the subsystems classes. So after that, you have to declare and implement this interface in a new facade class. The facade should redirect the calls from the client code to appropriate objects of the subsystem. So the facade should be responsible for initializing the subsystem and managing it further life cycle unless the client code already does this. So to get benefit, that means if you want to get a full benefit from the facade pattern, make all the client code communicate with the subsystem only via the facade. So all the requests from the client to the subsystems have to be made through facade. Now the client code is protected from any changes in the subsystem code. For example, when a subsystem gets upgraded to a new version, you will only need a modify. You have to only modify the code in the facade. If the facade becomes too big, consider extracting part of its behavior to a new refined facade class. ET++ application framework will use the facade pattern. So in the ET++ application framework, an application can be built-in browsing tools for inspecting its objects at runtime. These browsing tools are implemented in a separate subsystem that includes facade class called programming environment. Another operating system, Choices operating system, also uses facades to compose many frameworks into one. So the related patterns to the facade are abstract factory. This can be used with the facade to provide an interface for creating subsystem object in a subsystem independent way. And next one is mediator. Mediator is similar to facade. Mediator pattern is very similar to the facade in that it abstracts functionality of existing classes. So usually only one facade object is required. So thus the facade objects are often singletons. Thank you. Thank you for your attention, and in the next lecture we'll see another design pattern.